All right, let's dive right into this explainer. You know, if you really want to master software engineering foundations, you've got to understand the why behind the workflows. Today, we're tracing the evolutionary journey of software development, from those rigid old-school methods to the fast-paced, highly adaptable systems used by the top tech companies today. We're going to cover 6 core areas today: software engineering foundations, traditional SDLC models, the Agile revolution, mastering the Scrum framework, Agile mechanics and estimation, and finally, tools and team communication. Let's get to it. Section 1, Software Engineering Foundations, the basics. To really grasp modern frameworks, we first have to recognize the inherent chaos of building software. Enter the SDLC, or Software Development Lifecycle. Without this overarching process to design, develop, and test, well, software development is just a bunch of people typing in the dark. The SDLC is that foundational solution. It gives us a repeatable structure, making absolutely sure we deliver high-quality, working tech on time, instead of ending up with a tangled mess of broken code and frustrated developers. Section 2, Traditional SDLC Models, the Waterfall Era. Think of the traditional waterfall model kind of like building a skyscraper. You've got your requirements in month 1, design in month 2, implementation from months 3 to 5, testing in 6, and deployment in month 7. You need absolutely perfect blueprints up front. You execute in a strict sequence, and because of that, man, it is incredibly hard and wildly expensive to change anything once that foundation is poured. But here's the ultimate clash between theory and reality. Waterfall completely broke under the pressure of the real world. Why? Well, perfect foresight just doesn't exist. Clients inevitably change their minds right before launch, there's always scope creep, and moving targets are just a fact of life. Section 3, the Agile Revolution, embracing change. Because of that rigidity, the industry desperately needed a pivot, and the Agile Manifesto triggered exactly that. valuing individuals and interactions over processes and tools, and responding to change over following a plan. We went from building skyscrapers to something more like painting a portrait. Instead of locking in a massive year-long plan, teams iteratively adjust based on constant feedback. Make no mistake, Agile wasn't just some trendy buzzword. It's an iterative, flexible approach built on 4 core values and 12 principles. It was born specifically to solve Waterfall's inability to handle changing demands. It essentially gave developers the permission to actually adapt. Section 4. Mastering the Scrum Framework. Agile in action. So Agile is the philosophy, but Scrum is the most popular way to apply it day to day. A really great mental model here is the trio of 3s. You've got 3 core roles guiding the work: the visionary product owner, the protective Scrum Master, and the development team. And then you have 3 artifacts tracking the work: the big product backlog, the immediate sprint backlog, and the final working increment. Now, how does this translate into an actual workflow? Imagine a development team huddling together to battle through a standard 2-week sprint. They use exactly 4 sequential events: sprint planning to figure out the work, the daily scrum to sync up, the sprint review to look at the finished features, and the sprint retrospective to figure out how to be even faster next time. Section 5, Agile Mechanics and Estimation. Math behind magic. Before a team can estimate anything, they've got to write user stories. And the invest mnemonic is an absolute goldmine for product teams here. Tasks need to be independent, negotiable, valuable, estimable, small, and testable. Filtering tasks through these criteria ensures massive projects are broken down into perfect, bite-sized chunks that can actually get done. Once a story is written, we size it using story points. This is a unit of measure expressing the overall relative effort required to fully implement an item. Notice we aren't estimating in exact hours here. We're estimating in relative effort. It's a brilliant shift because it automatically bakes in complexity, unseen risks, and the natural uncertainty of writing new software. And to assign those points, teams use the Fibonacci sequence: 1, 2, 3, 5, 8, 13, 21. During a process literally called planning poker, the team will play cards with these exact numbers to reach a consensus on how big a task is. If a task is a 21, it's a huge lift. If it's a 2, well, it's just a quick fix. Over time, we track those completed points across consecutive sprints, like 20 points in Sprint 1, 25 in Sprint 2, 30 in Sprint 3. This visualizes a vital metric called team velocity. An upward trend shows that a team is getting faster and more efficient as they find their rhythm together. Let's pause for a quick pop quiz. If you're ever challenged in a technical interview or by stakeholders to defend the math behind Agile, how do you explain team velocity, and why does it actually matter? Here are the key takeaways you absolutely need to lock into your memory. 1, it's the total sum of story points completed in a sprint. 2, it's calculated by averaging past sprints. And 3, it's totally vital for predicting capacity and future delivery timelines. This is exactly how you forecast predictability in a highly unpredictable environment. Section 6, Tools and Team Communication. Staying aligned. When it comes to the actual software teams use, here's a great quick heuristic for you. Use Jira for heavy enterprise-level tracking, where you have highly customizable, complex issue tracking. On the flip side, use Trello when you just need simple visual Kanban boards, ideal for lightweight workflows and smaller teams. But you know, the tools only matter if the communication is right. Look at how effective Agile teams spend their energy. 30% on daily Scrum syncs, 50% on ad hoc Slack collaboration, and just 20% in formal planning meetings. Healthy Agile teams spend significantly more time in quick, spontaneous problem solving than they do trapped in formal planning rooms. As we wrap up, I really want you to remember this core truth. The ultimate goal of Agile is adaptability, not just speed. Moving from the rigidity of the waterfall model to modern frameworks is entirely about surviving and adapting to a world that literally changes by the minute. Speed is just a byproduct. Adaptability is the real goal. I'll leave you with this provocative thought. As AI begins writing more and more code, is Agile our final evolutionary step, or will new technology force us to write an entirely new manifesto? How will our frameworks change next? Keep questioning, keep adapting your own skills, and you'll be ready for absolutely whatever the tech industry throws at you. Thanks so much for joining me.
Hey everyone, and welcome to This Explainer. Listen, if you're currently staring down the barrel of a major exam, or maybe you're prepping for a massive tech interview, well, you are exactly in the right place. Today, we're taking a comprehensive guide on software engineering, and we're stripping away all the fluff. We're going to focus in on the absolute core concepts together, so you walk away totally prepared.
Because, it all really starts with this one massive fundamental question. How on earth do you build software without the whole thing just completely falling apart? Think about it. Millions of lines of code, dozens of developers, requirements that are constantly changing. Honestly, it's a recipe for total chaos. So we are going to look at the exact frameworks the industry uses to guarantee that what actually gets built actually works.
Okay, let's dive into this. Here's our game plan for today. 1. Software engineering basics. 2. Meet the SDLC. 3. Traditional SDLC models. 4. The Agile revolution. And finally, 5. Ace the interview.
All right, let's kick things off with Module 1, Software Engineering Basics. Let's look at the classic textbook definition first. Software engineering is the systematic, disciplined, and quantifiable approach to the development, operation, and maintenance of software. Now, I want you to really notice those three words: systematic, disciplined, quantifiable. We are not just hacking together some code in a dark basement here. We're applying rigorous, true engineering principles to digital products to ensure quality, scalability, and maintainability. Expanding on that just a bit, the primary objectives here are all about producing reliable software, but doing it on time and within budget. The characteristics of a truly good software process mean that it's highly predictable and testable. And the software process itself? Well, that's really just the structured set of activities required to build the system. Without this level of discipline, projects absolutely spiral out of control, budgets explode, and users end up super frustrated. Which brings us right to Module 2. Meet the Software Development Lifecycle, commonly known as the SDLC. Every single piece of software goes through these 6 standard phases. First up, planning and gathering requirements. Second, design. This is where you're architecting the solution. Third, coding or implementation. Fourth is testing, basically trying to break what you just built. Fifth, deployment out to the users. And sixth, ongoing maintenance. And this brilliantly illustrates how following a logical flow entirely prevents cognitive overload and keeps dev teams perfectly aligned from day one. Let's move on to Module 3, Traditional SDLC Models.
Software development has really been quite the evolutionary journey. Back in the 1970s, we had the waterfall era, super highly structured and very rigid. By the 1980s, as software inevitably got way more complex, we saw the rise of the iterative and spiral models, which started introducing cycles. And then, the 2000s brought the massive agile shift, prioritizing adaptability above all else. Let's actually break these down one by one.
The waterfall model is pretty much exactly what it sounds like. It's a linear sequential approach. Think about it. Water only flows down, right? So you absolutely must completely finish the planning phase before you can even start design. You must finish design before coding. The working mechanism is incredibly straightforward, but, well, here's the catch. Discovering a massive bug right before launch in the testing phase, that's kind of like building a house and realizing you forgot to install the plumbing after all the walls are already painted. It is incredibly painful to go back.
Now, Waterfall's advantages are definitely its simplicity and its clear structure. It is wonderfully easy to manage because the milestones are totally rigid. But the disadvantages? It is terribly, terribly inflexible. It's really unsuitable for projects where requirements might change down the road. It's best used for short, super well-understood projects, like, say, a simple payroll system, where the rules are clearly defined by law and they just won't shift halfway through development. But as the digital world moved faster, rigid waterfall just couldn't keep up. Enter the iterative and spiral models. Iterative develops software in repeated cycles, so you're building a small piece, reviewing it, and then improving it. The spiral model takes that exact same cyclical approach, but adds a really heavy, intense focus on continuous risk analysis at every single loop. The pros here are massive. Both are highly adaptable, and spiral is practically unmatched for risk management. If you are building mission-critical software, like a medical device or a back-end for a massive bank, spiral is absolutely your best friend. However, the drawbacks are that these models are complex and they can be quite costly to manage. You're going to need highly skilled risk analysts, and honestly, the documentation alone can become a total mountain of its own. So, the crucial point is, when we contrast these directly, the differences are night and day. Waterfall is linear and rigid, best for simple projects. Iterative builds in chunks.
spiral loops with high-risk analysis for critical systems. And Agile, which we are going to discuss next, well, Agile is highly flexible and all about collaboration.
All right, Module 4, the Agile Revolution.
Picture this. In 2001, 17 software developers met and wrote what became the Agile Manifesto. It was a major turning point that successfully and permanently challenged those traditional models. The most famous line from it? Individuals and interactions over processes and tools. They finally realized that building software is, at its core, a human endeavor. And being able to respond to change is infinitely more valuable than just blindly following a pre-written plan.
So Agile isn't just a strict set of rules, it's really a mindset. It's built on 4 core values and 12 guiding principles. It explicitly prioritizes working software over comprehensive documentation, customer collaboration over strict contract negotiation, and responding to change over following a plan. Instead of building up to one massive, risky launch, Agile teams work in short sprints. They deliver tiny, fully functional pieces of the software continuously. And guys, this methodology absolutely dominates the tech industry today. But hey, let's look at it objectively. The benefits of Agile are incredibly clear. It is super fast, it's flexible, and it keeps the customer happy through constant ongoing feedback. Think of a nimble startup pivoting an app's features based entirely on real-time user data. That's Agile in action. However, the drawbacks include what we call scope creep, where the project just never seems to actually end. And it requires intense, daily collaboration, which honestly can lead to serious developer burnout. It demands a highly communicative team. All right, home stretch, Module 5, Ace the Interview. Time to get you ready.
Let's look at the standard exam and interview questions you are almost guaranteed to face. An interviewer will almost certainly ask you to define SDLC and explain its phases. They'll ask you to compare Waterfall and Agile. They'll ask exactly why the Agile Manifesto was created in the first place. But if you've been following along, you already know the answers. SDLC is the structured process. Agile beats Waterfall in adaptability but loses in predictability. And the Manifesto? Well, that was born entirely out of frustration with rigid, slow, documentation-heavy processes. To really drill these concepts home for the long haul, use memory tricks. For the 6 SDLC phases, planning, design, coding, testing, deployment, maintenance, just remember the acronym, Please Do Code to Deliver Magic. Seriously, say it with me. Please do code to deliver magic. It works. And when you need to remember Agile's core, just think people, working software, collaboration, change. Lock those revision notes in, and I promise you will never blank during a test or an interview.
Now, what's really interesting about this next scenario is how it tests your deeper understanding. When would you choose the spiral model over Agile? This is a classic trick question interviewers love. The answer? You choose spiral when risk mitigation is your absolute highest priority and budget is less of a concern. Look, Agile is fantastic for a social media app, but spiral? Spiral is what you use when you are coding the launch sequence for a literal rocket ship, where failure is absolutely not an option. Okay, here is your final checklist. Can you define software engineering? Yes, it's systematic and disciplined. Can you list the SDLC phases? Please do code to deliver magic. Can you contrast waterfall, iterative, spiral, and agile? Yep, based on rigidity, cycles, risk, and adaptability. If you can confidently answer these right now, you are fully prepared and totally interview ready. We have traveled all the way from the rigid waterfalls of the 1970s to the lightning-fast, agile sprints of today. But as we know, software engineering never actually stops evolving. So I want to leave you with this final provocative thought. With Agile completely dominating today and AI literally starting to write its own code, what do you think the next revolution in software engineering will look like? Keep exploring, keep learning, and I'll see you in the next explainer.
So let's just dive right into this explainer. Look, studies actually show that we forget up to 70% of new information within 24 hours if we don't structure it the right way. It's crazy, right? So if you've ever found yourself staring at a super dense technical manual or some wildly complex piece of code or even an abstract math concept and just thought, man, how on earth am I going to learn this, let alone explain it to someone else? Well, you're in the exact right place. What we're deconstructing today is literally the ultimate meta blueprint. We're talking about a systematic, step-by-step methodology pulled straight from our source material that takes the pure chaos of complex info and transforms it into rock-solid, unshakable comprehension. Let's quickly hit today's agenda. First up, we've got the 5 pillars of explanation. Then, visualizing complex information, followed by grounding in reality. and we'll wrap up with the testing and retention strategy. All right, jumping right into Section 1, the 5 pillars of explanation. This is where the magic happens. This framework brilliantly illustrates a strict sequential methodology that you absolutely have to follow to build total comprehension. It moves you from the basic what to the ultimate why. And here's the kicker. According to the framework, you really can't just skip around. You can't start with why it's important before actually defining what it is. And there's no way you should show a calculation without the underlying formula. It's this rigid 5-step cognitive journey. Whether you're learning it yourself or teaching it to a room full of people, you have to walk through these specific gates in this exact order to make sure absolutely no foundational gaps are left behind. So let's break these down step by step. Okay, step 1. Every single successful technical study guide has got to start right here, grounding the learner with a crystal clear definition before you even think about introducing any complexity. Think of the definition kind of like declaring variables at the very top of your script in programming, or laying down the foundational axioms in a math proof. Before we can compile all that complex logic, we have to establish the absolute facts we're working with. The framework demands that you explicitly isolate this foundational concept, because honestly, if your definition is fuzzy, every single step that comes after it is just going to collapse under its own weight. All right, moving on to steps 2 and 3. This is where we have to mathematically or logically prove exactly how the concept works. Handing someone a formula is great. It gives them the structural rule, but you must immediately follow that up with an example calculation. Take some dummy data, like the number 100, and just run it through the formula so the learner can actually see that mechanical transformation happening right in front of their eyes. You really can't just talk about a concept in the abstract. You've got to pop the hood and show the engine actually running. So, okay, we've run the numbers and we have our output, 100. But what does that 100 actually mean? Is it a passing grade, a fail, a critical system error? This right here is where so many textbooks and presentations just completely drop the ball. They give you the math, they show you the calculation, and then they just stop. But the framework demands we hit steps 4 and 5, importance and interpretation. Why does this concept even exist in the real world? You absolutely have to interpret that output if you want to secure true, lasting mastery of the topic. Moving on to Section 2, visualizing complex information. Look, to prevent your explanation from reading like the terms and conditions of a software update, because nobody actually reads those, right? You need to inject visual structure. The source material strongly advocates for immediate visual relief. Think about how exhausting it is to slog through paragraph after paragraph just describing a process. It's brutal. By using ASCII diagrams, which are actually super great for simple text-based code environments, alongside workflow diagrams, you're mapping out systems spatially. You are literally showing the flow of information. It takes all that invisible logic and makes it suddenly visible and honestly incredibly easy to follow. Furthermore, anytime you're dealing with categorical data or comparing things, you need to lock that data cleanly into a grid. As a rule of thumb, sequential data gets a workflow diagram, but categorical data gets a table. It makes it instantly digestible. Tables are amazing because they force you to be concise. They let the learner's brain rapidly scan for relationships and differences without getting totally bogged down in heavy, dense syntax. All right, let's shift gears to Section 3, grounding in reality. Listen, if you want to absolutely nail your next technical presentation, you must include real-world examples. Abstraction is literally the enemy of retention. You could have the tightest definitions and the most beautiful tables in the world, but if the learner doesn't understand how this applies to their daily life or their actual 9-to-5 job, I guarantee they'll forget it by tomorrow. The framework insists that you take this technical subject and drop it right into a real-world scenario. Show them how a specific tech company uses this exact code to solve a massive problem, or how a specific math principle literally keeps a bridge from collapsing. You have to ground it in reality. And that brings us to Section 4, testing and retention strategy. When you're putting together your next study guide, you have to include 2 very different types of questions: exam questions for rigid testing and interview questions for interactive conversational validation. This dual-pronged approach is actually super fascinating. Exam questions. They test your raw recall. We're talking multiple choice, true or false, fill in the blanks. Basically, do you know the exact parameters of the formula? But interview questions are an entirely different beast. They test whether you can actually explain the core importance and interpretation to another human being in real time. Like, can you defend your knowledge on the spot? The framework insists that both types of testing are absolutely mandatory. This whole testing phase is crucial because it forces the learner to actively engage with the material rather than just passively consuming it. It's really easy to just nod along while reading a beautifully formatted study guide and totally trick yourself into thinking you understand it. We've all been there. But the second you're confronted with a direct question, that illusion of competence just shatters. You either know it or you don't. By baking these questions directly into the learning framework, you are forcing immediate, real-time self-correction. Ultimately, this entire framework culminates in the creation of quick revision notes. This gives you that vital, condensed review sheet for those final sweaty moments right before a big test or a major interview. Think of it as the ultimate distillation of every single thing we've just covered. You take the definition, the formula, the interpretation, and the absolute best real-world example, and you shrink all of that down into a highly concentrated reference sheet. Now, keep in mind, this isn't meant to teach you the subject from scratch, not at all. It's a trigger for your memory, specifically designed to rapidly pull all that deep, foundational knowledge you just built right back to the front of your mind. So we've seen exactly how to build an explanation from the ground up, starting with definitions and formulas, moving all the way through interpretation, visualizing the data, grounding it in the real world, and then finally rigorously testing it. The next time you're faced with a totally daunting technical topic, don't just stare at it and panic. Break it apart using these specific pillars. If you apply this framework, I promise you, it will transform how you learn forever. So the only question left to ask is, what complex technical hurdle are you going to deconstruct and master first? Welcome to the Explainer. Look, if you're trying to figure out how modern software teams actually operate and you want to completely demystify Agile project management, well, you are in exactly the right place. Today, we're tearing down the absolute essentials of Agile frameworks. We're going to focus on the heavy-hitting tools and, honestly, the most critical part, the human communication that makes those tools actually work. All right, let's look at our roadmap for today. We'll start with a quick welcome to Agile frameworks, decode Jira, and then explore Trello, which is basically a giant visual whiteboard. After that, we've got a Jira versus Trello showdown, a deep dive into team communication workflows, and we'll wrap the whole thing up with some crucial exam and interview prep. Section 1. Welcome to Agile Frameworks. We are kicking things off with the absolute foundational concepts you're going to need before walking into literally any tech environment. You hear the word Agile thrown around a lot, right? But to really grasp it, we have to strip away the corporate jargon. Basically, Agile is a structured, iterative approach to software development. It relies heavily on specialized tracking tools and continuous team communication to get functional products out the door efficiently. The crucial takeaway here is that Agile isn't just one single thing. It's this beautiful marriage of specialized tools and constant human interaction. The key word? Continuous. Instead of building some massive product in total secrecy for a year, just hoping the client likes it at the end, Agile teams build in small, continuous chunks. But to keep track of all those moving pieces without descending into total chaos, you absolutely need powerful systems and a team that talks to each other constantly. Section 2. Decoding Jira. Let's move on to our first major tool, which is basically the complex command center for enterprise developers. If you're stepping into the enterprise software world, you are 100% going to encounter Jira. And man, when dealing with complex, massive project data, Jira is absolutely packed with features. It breaks things down into different issue types. So a massive project, an epic, can be broken down into manageable tasks or used to track unexpected bugs. You get this incredibly comprehensive dashboard that gives you a true bird's-eye view, along with support for both Scrum boards for time-boxed sprints and Kanban boards for continuous flow. Plus, you can manage some seriously detailed sprint planning. The major advantage? It offers immense power and totally customizable workflows for complex projects. But the trade-off? Yeah, there's a notoriously steep learning curve. Honestly, it can feel like staring into an endless abyss for a junior developer on day one. Now, here's the classic Jira workflow in action. Back in the day, this was literally a physical wall covered in sticky notes, but now it's your daily digital journey. Everything starts in the backlog. That's your master list of all ideas and requirements. Then, when a sprint kicks off, selected items move over to to-do. Once you sit down and actively start coding, boom, it moves to in progress. And finally, the absolute best feeling in the world, moving that ticket into the done column. It's a great system because it transforms a static concept into an active, totally trackable pipeline. Section 3. Trello, the visual whiteboard. Now we're shifting gears to a tool that takes a much more physical, highly visual approach to project tracking. If Jira is your complex command center, think of Trello as your favorite set of colored markers. It's essentially a highly visible digital whiteboard covered in sticky notes. It relies on super intuitive boards, lists, and these great draggable cards. You can just throw on some color-coded labels to instantly categorize your tasks and even use built-in automation for those annoying repetitive actions. The big advantage here is the instant visual clarity. It is incredibly quick to set up right out of the box with some handy workflow examples. The flip side, though, you're definitely missing out on the in-depth reporting and deep analytics you'd get with something like Jira. Section 4. Jira versus Trello Showdown. All right, let's dive into the heavyweight comparison. Knowing how to use a tool is great, but knowing which tool to actually choose for a specific scenario, that's what makes you a leader. If you're taking revision notes, you might want to screenshot this comparison right now, because it perfectly breaks down the core differences. Let's look at the cost first. Jira scales up to higher enterprise-level pricing, while Trello offers a really accessible lower tier or even a completely free tier. For ease of use, as we mentioned, Jira demands a steep learning curve, whereas Trello is incredibly intuitive. When it comes to Agile support, Jira gives you advanced, strict Scrum and Kanban frameworks. Trello, it gives you a more basic, free-form Kanban-style layout. And because of Jira's deep, highly customizable reporting, its absolute best use case is for complex development projects. Trello, with its more limited reporting, really shines brightest in simple team workflows. Section 5, Team Communication Workflows. Okay, so we've mastered the toolbox. Now we really have to master the teamwork. Because in Agile, the tools are just the scaffolding. The actual building happens through human connection. As any Agile coach will tell you, even the most advanced Agile tools are completely useless without effective and continuous human communication. When you sit down for your very first project, the software is not going to save you if you can't talk to your team. Seriously. You could have the most perfectly configured Jira dashboard in the entire world, but if your developers aren't communicating their blockers, or if the stakeholders are left totally in the dark, the project is going to fail. Communication is literally the lifeblood of the Agile framework. So what does this actually look like day to day? Well, these are the essential daily and weekly rituals where the real work of an Agile team happens. It starts with daily stand-up meetings. Just a quick sync on what you did yesterday, what you're doing today, and if you're stuck on anything. Then you've got pair programming, where two developers share one machine and communicate constantly to crack complex problems. Alongside that, collaborative code reviews ensure high quality and help share knowledge across the team. At the end of a sprint reviews let you demonstrate the working product directly to your stakeholders. And crucially, really don't skip this, retrospectives provide a dedicated space for team reflection so you can figure out what went wrong and how to actually improve for next time. Now, let's talk about what happens when things go sideways. Like, say, a stakeholder suddenly changing their mind halfway through a sprint. It happens all the time. When communication breaks down, conflict naturally arises. So the best practice here is active listening and total transparency. Instead of getting into a massive argument over a 30-message email thread, just jump on a quick call, pull up the Kanban board, and visually show the stakeholder exactly how their new request is going to impact the current timeline. Conflict resolution in Agile is all about pointing at the work, not pointing fingers at the person. You use the tools to facilitate a factual, totally blameless conversation. Section 6, Exam and Interview Prep. Let's transition into some practical application here so you can totally nail your upcoming semester exams and job interviews. Theory is great, right? But applying this knowledge under pressure is what we're really aiming for. So imagine sitting across from a hiring manager and they hit you with this exact scenario. How would you choose between Jira and Trello for a newly formed Agile team? And how would you ensure effective communication from day one? Now, they don't just want you to recite a list of features here. They want to see your decision-making process. They want proof that you understand the delicate balance between software architecture and actual human dynamics. So here is your cheat sheet to answer that perfectly. First off, always state that you would assess the project's complexity and the team's technical maturity before doing anything else. You tell them you choose Jira if the project requires deep reporting, complex dependencies, and strict Scrum rituals. On the flip side, you choose Trello if the team really needs visual simplicity, rapid onboarding, and a flexible Kanban tracking system. But here is the real kicker for your interview answer. Emphasize that regardless of which tool you choose, you would prioritize establishing daily stand-ups and retrospectives immediately. Because ultimately, the tools just facilitate the work. It's the people who actually communicate and get it done. Which brings us to the ultimate question. You have the tools and you have the talk, but is your team actually Agile, or are you just doing Agile? I'm going to leave you to reflect on that final thought. I challenge you to ensure your future teams embrace the true Agile mindset, going way beyond just clicking buttons and moving digital cards from to-do to done. Because adapting to change, communicating transparently, and continuously improving, that right there is the hallmark of true mastery. Keep that in mind as you step into your next project. Thanks so much for joining me on this explainer, and as always, keep learning.